We have designed, implemented and tested SeaMo, a working implementation of Seamless Vertical Handover in Heterogeneous Wireless Network. Handoff process includes network monitoring, handoff decision and handoff execution phases. We have tested SeaMo on a hybrid testbed consisting of 3G, WLAN and emulated WiMAX network segments. Let us now look at the working of SeaMo. SeaMo works in three different phases: pre-handoff phase, decision phase and post-handoff phase. Let's assume there are n networks of different technologies and the host is connected to a particular network. The pre-handoff phase will scan these networks for various parameters and passes these scanned parameters to the decision module. If the algorithm decides to hand over, it will then trigger the post-handoff phase. The post-handoff phase will initiate a connection to the new network and then disconnect from the old network. Let us look at the working of the algorithm in detail. The first step is fuzzification. Each parameter considered for decision making will have a membership function defining the fuzzy sets like low, medium and high. Take an example of value 30.1. The fuzzy set for this particular value will be 0.3, 0.70, which says 0.3 low, 0.7 medium, 0 high. The second step is quantitative evaluation of input parameters. The quantitative evaluation value set for a particular parameter is chosen based on its characteristics and is multiplied by the fuzzy set obtained, which will give us the QEV of a particular parameter. The third step is quantitative decision values. The QEV of RSSI, link quality, bandwidth, cost and user preference for every network is calculated and fed to the algorithm module. The algorithm would generate QDV of a network I. The QDV of the network I and similarly obtained QDV of network J are sent to the decision module. The decision module compares them and decides handoff or no handoff. SeaMo implementation is available for Linux, Windows and Android platforms. We will begin the demo of SeaMo on Android platform. This is the GUI of SeaMo on Android. Initially, the user has to configure the networks for which the user has access to. We will first add a network. We add a Wi-Fi network whose ESS ID is home, and we also provide the cost of accessing this network. We will save this configuration. When we click on View Networks, we can see that the home network is added. Let us now add a 3G or a mobile network, and we also provide the cost for this network. We will give second preference to this network. We save this configuration. Here we can see that both the networks are added. By clicking on a particular network, we can view or delete the configuration of this network. After configuring the networks, we can go back and start SeaMo. But before we start, let us look at the path the user would take. This picture shows the labs in the corridor of ECE department, and this would be the path the user would be taking. Let us now start SeaMo. Observe that we are initially connected to the Wi-Fi network. Once SeaMo is started, we can see the RSSI and the decision metric QDV for the configured networks. Now we are seeing the user walking through the corridor towards the foyer. The user continues to walk towards the entrance of the department. Meanwhile, let us look at the graph which shows how the RSSI is changing. We can see that the RSSI of Wi-Fi network has been decreased and the RSSI of 3G network is increasing. Now let us look at the changing QDVs of Wi-Fi and 3G network on the Android screen. Look at the changing QDVs. We expect a handover to occur. And there you see a handoff to 3G network. Observe that we are now connected to a 3G network. Let us quickly glance through SeaMo on Windows platform. The window towards the left shows the GUI of SeaMo and towards the right the video of the user walking. As you can see in the pop-up below, the user is initially connected to the home network. which is a Wi-Fi network. The user follows the same path shown previously. As the user passes the foyer and walks towards the entrance of the ECE department and hence away from the Wi-Fi network, we see the QDV of the Wi-Fi network decreasing gradually. We also observe that the QDV of the 3G network is increasing. As the user approaches towards the 3G network, we expect an handover to occur. And there you see handoff to 3G network. Look at the pop-up which shows that now we are handed off to 3G network. This graph shows how the QDV of Wi-Fi and 3G networks have changed and where the handoff occurred. By this, we complete the demo of SeaMo on Android and Windows platform.